Welcome to another episode of Fort Bend Mathematics Tutoring. Take a moment to soothe your nerves. Remember, these is just numbers. They can't hurt nobody.
Hello, ladies and gentlemen. This is Mr. Witt with Fort Bend Tutoring, and today's lesson is about multiplying binomials. That's right, two terms times two terms. And here's an example of the format. So basically, anytime you have two binomials, two sets of parentheses with two terms each within them, then you can use two different strategies in order to solve this. One, you can use my favorite, which is the distributive property, meaning that I got my arrows popping here, because that's what my arrows do. And you would end up multiplying the first term times both terms in the second set of parentheses, and you would multiply the second term also by both terms in the second set of parentheses. Therefore, you would end up with these following products. You would end up with A times C plus A times D plus B times C plus B times D. And that's just simply distributing each term in the first set of parentheses times everything in the second set of parentheses, which is what I prefer. However, they have simplified the process in such a way that they've defined it as the following. They say that you can multiply the first terms together, meaning that A and the C term. You can then multiply the outer terms together, meaning A times D, then multiply the inner terms, B times C, and finally the last terms in each set of parentheses, meaning B times D, to end up with FOIL, aka the FOIL method. Now, I preferably just simply do the distributive property because the FOIL method is just something extra for students to learn, and it's the same thing. That's right. The distributive property, multiplying A times C, A times D, B times C, and B times D is the exact same thing as the FOIL method, ladies and gentlemen. So students, please understand this, as well as teachers, that when learning the FOIL method, all you're doing is distributing, okay? So if you don't want to have to learn what the F, the O, the I, the L stands for, then just simply multiply everything out and you'll be fine. Just fine. All right, so let me show you that. Let's start out with the first problem here. Here, with problem number 1, I have the quantity of x minus 3 times x plus 5. So what I'm going to do first and foremost is get my arrows popping, all right? So I know that I'll be multiplying this x times both terms in the second set of parentheses, as well as taking this negative 3 and multiplying that times both terms as well. So I'll end up with the following results. X times x will be x squared. X times 5 is 5x, and notice how I circled that negative 3. That's reminding me that that second term in the first set of parentheses is negative. So keep up with that, all right? So here we'll have negative 3 times x. That'll give me negative 3x, and finally negative 3 times 5 is negative 15. And for those of you that love the FOIL method, we did the exact same thing as you. We multiplied the first terms together, meaning that x times x. We multiplied the outer terms, meaning x times 5. We multiplied the inner terms, negative 3 times x, and finally we multiplied the last terms, those second terms in each set of parentheses, that negative 3 and the 5 together to get the negative 15. Keep in mind that when you're looking for terms, when you're searching for terms, terms are always separated by plus or minus signs, okay? So here in that first set of parentheses, the first term is x, second term is negative 3. In the second set of parentheses, the first term is x, the second term is positive 5. Now, once you finish distributing, you always look to see if you can combine any like terms. So notice that my middle terms here, that 5x and negative 3x, they both have x to the first power, meaning and making them like terms. So let's add them together. So I'll bring down my x squared. 5x minus 3x is going to give me a positive 2x. And finally, I'll bring down my positive 15 and done. That's it. You got it. So I'm going to put a red box around my answer because that's what I like to do always. So that's the process of multiplying binomials. All right, just like that. All right, and you know what? I think I'm going to switch up pens here. And so let's pull out this one. Okay. All right, there we go. For problem number 2, I have the following. I have 2x minus 7 times 8x plus 1. So once again, I'm going to start by getting my arrows popping. I'm going to circle that second term because it's a negative, so I won't forget that. And finally, I'll start multiplying this out. So 2x times 8x gives me 16x squared. I then have 2x times 1, which is 2x. Next, I'll have negative 7 times 8x gives me a negative 56x. And then I have negative 7 times 1, which is negative 7. Once I've finished multiplying that out, I'm going to write my answer in descending order of x, meaning that I'm going to start with the term with the highest exponent and work my way down. So if you're ever concerned about what order to put your terms in, always write your answer in descending order of your variable unless told otherwise. All right, so let's bring down this 16x squared. I'll be combining my middle terms together, meaning that 2x and negative 56x. That gives me a negative 54x, and I'll bring down this negative 7. And that's the answer. That's it. I'm going to put a red box around that. Okay, there it is. You got it. So let's keep going. All right, next problem. I have the quantity of x minus 5 times 14x minus 3. Once again, I'm going to get my arrows popping. That's right. Get those arrows popping, ladies and gentlemen. Okay, so here we are. I'm going to multiply x times 14x. That gives me 14x squared. I have x times negative 3, which is negative 3x. Next, we have negative 5 times 14x, which is negative 70x. And I also have negative 5 times negative 3. Remember that a negative times a negative is a positive. So I'll end up with a positive 15 as that last term. Once we finish distributing, remember your next thing to do is to combine like terms. That's right. So look for any terms that can be added or subtracted together. So we do have our middle terms negative 3x and negative 70, which can be combined. So I'll be bringing down this 14x squared here. And see, like signs you add, all right, and you keep the sign of the biggest term. So I'm going to bring down a negative 73x. Remember, like signs add, unlike signs subtract. Always keep the sign of the largest number. Then I'll be bringing down that positive 15. All right, and that's the answer. Let's put a box around that. There we go. In problem number 4, we have 4a minus 3 times 4a plus 3. So what I'll be doing here is I'll be distributing, all right, getting my arrows popping. I'm going to circle that second term there because it's negative, all right, and it won't always be negative, but anytime that second term is a negative sign, I prefer to remind myself that it's negative by putting a circle around it, all right? Then continuing on, I have 4a times 4a. That'll give me 16a squared. I next will have 4a times 3, which is going to be 12a. Then multiplying negative 3 times 4a, that'll give me a negative 12a. And then I have negative 3 times 3, which is negative 9. Notice that we always will distribute and then combine any like terms that we may have. These two middle terms are like terms, but they're also additive inverses, meaning that they're opposites of one another. Anytime you're trying to combine opposites, it equals to 0. In other words, these 12a's will cancel out. All right, they're gone. So you'll just end up with 16a squared minus 9. And this type of binomial here, this 16a squared minus 9, is called a difference of squares, a difference of two squares. So if you ever want to figure out how to factor, in other words, get back to your original, all right, that 4a minus 3 times 4a plus 3, go ahead and check out our video on difference of squares, ladies and gentlemen. All right, so here we're multiplying, but in the other one you'll be factoring. So if you need a lesson on that, check that out. All right, I'll put a link in the description box. All right, good deal. So that's problem number 4. All right, and now we're off to the next problem. Let's check it out. All right, for problem number 5, we have the quantity of 2m minus 3 squared. Anytime you have more than one term inside of a set of parentheses and you have an exponent on the outside of it, do not, repeat, do not distribute the exponent inside the parentheses. You can't do that, all right? It's not mathematically correct. Instead, what this means is that you have this binomial, this 2m minus 3, raised to the second power, meaning you have 2m minus 3 times 2m minus 3. That's right. You have that quantity, that 2m minus 3, raised to the second power, meaning multiplying against itself. So you must expand it, in other words. So your first step when doing a binomial squared is to expand it, and so it'll look like the previous problems that we were dealing with when we were multiplying a binomial times a binomial, which means we can apply the distributive property and or the FOIL method, okay? So here I'm going to get my arrows popping. You got it. You can get those arrows popping here. Okay, so let's go ahead and multiply this out. We have 2m times 2m. That gives me 4m squared. 2m times negative 3 is negative 6m. Negative 3 times 2m is negative 6m. And finally, negative 3 times negative 3 will give me a positive 9. All right, so once again, anytime you finish distributing, you always look to see if you can combine your like terms, those terms that have the exact same variable with the exact same exponent on those variables. All right, so let's bring down our 4m squared first. All right, then I'll end up with my negative 12m Bringing down that positive 9 and done. All right, so what do you say that you don't like that for? All right, I'll fix it. All right, I don't know. Is that better? All right, therefore it's better. So we have 4m squared minus 12m plus 9 as your result. And that's it. All right, let's go ahead and put a box around that. So next, let's look at problem number 6. For problem number 6, we have another binomial squared. Remember, anytime you have a binomial squared, you're going to expand it. You're going to rewrite it by multiplying the 4x plus 9y times itself. Yeah, 4x plus 9y. So that's going to be your first step anytime you see a problem such as this. Do not distribute the exponent inside of the parentheses, all right? That is not the proper way to do it. So here, we're going to go ahead and multiply everything out after I get my arrows popping. Let's not forget to get those arrows popping. And finally, that second term is positive, right? So you'll have 4x times 4x. This gives you 16x squared. You'll have 4x times 9y. That'll give you a 36xy. Notice that I'm writing my variables in alphabetical order, and I'll always do that, and that helps me identify my like terms, by the way. So here I'll have 9y times 4x, and once again, this will give me 36xy. And then finally, I have 9y times 9y, which is going to give me a positive 81y squared. Once I've done that, I'm going to attempt to combine any like terms I may have. And once again, you identify like terms by those terms that have the exact same variables with the exact same exponents on those variables. And that's exactly what we have with our middle terms here, so we can combine those. So I'll be bringing down this 16x squared. Adding our middle terms together, we have a positive 72xy. And finally, it'll be a positive 81y squared as the last term there. And this is the answer. That's it. All right. Okay, let's check out the next problem. All right, in problem number 7, we have the quantity of 3x minus y times 2x plus 5y. So what I'll be doing, once again, is I'm going to start out by getting my arrows popping here. Second term is negative, so I'll be distributing that as well, making sure that I know that the second term is negative. And starting out, I'm going to multiply 3x times 2x. That gives me 6x squared. I then have 3x times 5y, which gives me a positive 15xy. Then multiplying negative y times 2x, that gives me a negative 2xy. And then finally, negative y times 5y gives me a negative 5y squared. All right, so next I'm going to combine my middle terms, and I'm going to write my answer in descending order of x, meaning I'm starting with the term that has the highest exponent on my x variable, and that'll be the first term. So this is going to be the 6x squared, then combining the 15xy minus 2xy, I end up with a positive 13xy, and then I'll be bringing down that negative 5y squared. Okay, and that's going to be the answer there. That's it. Done and done. Now it's problem number 7. Just like that. Let's move on. Last problem, ladies and gentlemen. We have problem number 8 here. And in problem number 8, we have 5x squared y plus 3z times 11x minus z. So let's see what happens with this problem. All right, so I'm once again got my arrows popping. I'm going to distribute that 3z to both terms in the second set of parentheses. So multiplying 5x squared y times 11x, I end up with 55 x cubed y. Remember that your exponents, when you're multiplying like bases, they add. So I had x squared here, I have x to the first power here, so that 2 plus 1 gives me x to the third power, and then my variable y. Then I'll be multiplying 5x squared y times negative z. That gives me negative 5x squared y z. Notice how I'm writing these variables in alphabetical order. That's right. A, B, C, D, E, F, G, you know the rest, right? Okay, then we're going to multiply 3z times 11x. That gives me a positive 33xz. All right. Once again, the purpose for writing your variables in alphabetical order is to help you identify any like terms when you're finished multiplying. So please do that every time. Then we'll be multiplying 3z times negative z. That gives me negative 3z squared. After we distribute, we always look to see if we have any like terms. Looking at each of these 4 terms, ladies and gentlemen, you will notice that every term has a different combination of variables and exponents, meaning that you don't have any identical variables with the exact same exponents on those variables. They're all different. This first term has x cubed y, second term has x squared yz, the third term has xz, and then the last term has z squared. So none of these four terms here are like terms. Because of that, this is our answer. We won't be able to add or combine any of these. All right, so that'll be your final result. Well, ladies and gentlemen, that does it for Mr. Witt and Fort Bend Tutoring. This was Multiplying Binomials. As always, please comment, rate, subscribe, and if you're able, ladies and gentlemen, please donate, because that helps us bring more free videos to you. All right, take care. Bye-bye.
We certainly hope you enjoyed today's mathematics presentations. Did you learn anything? Do you need to review your notes? Take a deep breath and congratulate yourself. I am learning mathematicals.